Hey guys, and welcome to this video. So in this video, I'm going to be talking about OSI model layer 2 or the data link layer. Let's quickly recap what we talked about in the last video. In the last video, we talked about OSI layer 1 or the physical layer. And the physical layer handles physical transmission of data. And as a result, it defines a lot of hardware specifications. It contains many different components, including the transmission media, encoding and decoding methods, pinouts, signaling, and network interface card. Now, there are many issues that we need to deal with when transmitting in the real world, and the design of the components and the combination of components reduces the impact of these issues. I also talked about topologies, and topologies are the physical arrangement of devices, and different arrangement of devices provide different properties and benefits to a network. I also touched upon some stuff beyond networking, and because networking is more than just networking specifications, the location and storage of your equipment, the power that's being delivered, the weather, humidity, and more affect the well-being of your network. And that has many implications from a security, design, and operations perspective. So lastly, I talked about the devices at layer 1, and these include the hub and the repeater. The hub contains many ports and just copies the data coming in to all the other ports. A repeater takes the incoming signal and amplifies it and sends it out to the outgoing port. Let's talk about the data link layer. Now, in physical layer, it dealt with the physical transmission of data in the real world. And in the data link layer, it deals with the logical transmission of data between two devices on the same network. The data link layer contains two sublayers. First is the media access control layer, or the MAC layer, and the second is the logical link control layer, or LLC. There are different types of networks. First is called the LAN, or local area network, and that is a network of devices that are within a small area, or generally within the same building. Next, we have the WAN, or wide area network, and that is a network of devices that are over long distances. And then we have MAN, or the metropolitan area network, and that is a network of devices that span a city, a town, or something similar. Lastly, we have the GAN, or the global area network, which is a network of devices that span the entire globe. Now, in practice, LAN and WAN are used the most, so make sure you know what those mean. The MAN might be used in bigger enterprises where you have data centers and multiple offices within the same city. And now let's get into the logical link control sublayer. The LLC sublayer defines the protocol format and encapsulation of packets into frames and decapsulation of frames into packets. Now, in this layer, you can also perform error detection and correction and flow control. Now, in practice, flow control is not really used in this layer, so we're only going to talk about error detection and correction. Now, as we learned in the last video, the physical layer is not perfect and it may result in errors during transmission. And in order to detect and or correct errors, a calculation is performed per frame and value is appended to the frame. Now, for error detection, a frame is discarded if one or more errors are detected. And the side effect is if the error detection value gets corrected during transmission, then the frame is discarded as well. Now, in error correction, the number of errors up to a certain point can be corrected, and anything beyond that limit requires the frame to be discarded and transmitted, just like in error detection. Let's now move on to the media access control sublayer. The MAC layer defines physical addressing and methods to access the physical media. Physical addressing is relatable to why we need addresses in the real world. We need to be able to uniquely identify devices in a single network. Now, the physical addresses are often called hardware addresses, and because the hardware or the physical address is hard-coded into every NIC, which makes it unique. Different protocols use different physical addressing schemes, but the most common is called the MAC address, and you might be familiar with the MAC address from Ethernet networks, Wi-Fi networks, or even Bluetooth. Now, manufacturers need to make sure that physical addresses are globally unique because they cannot have duplicate addresses on a network. Now, the caveat with that is a physical address or hardware address is potentially customizable in software. And while that creates interesting applications and potentially services, that also creates potential security issues. And we're going to talk about it in a future video. Once we have physical addresses, we can now communicate. And there are several different types of communication. First is called unicast, and that's a communication where the destination is a single receiver. Next, we have multicast, and that's a communication where the destination is multiple receivers. And lastly, we have broadcast, and that's a communication where the destination is all devices on the same network. And specifically, when you have a group of devices in the same network that receive broadcast traffic, that is called a broadcast domain. And special physical addresses may be reserved for multicast and broadcast. For unicast, you just send directly to the hardware or physical address of the NIC. In order to communicate, you need access to the physical medium, and depending on the network, devices may share the same physical transmission medium. When multiple devices communicate on the same medium at the same time, it causes collisions. And protocols in the max sublayer define who can communicate at a given time in order to avoid collisions in a shared medium. And that is called the multiple access method. And a collision domain is a group of devices that cause a collision on the physical media if they transmit at the same time. There are a few devices that operate at layer 2 besides the network interface card. First is the bridge, and second is the switch. Now here we're only going to talk about a switch because it is basically a superset of the bridge. It has more intelligence, it has more ports, and it has faster performance. Switches contain many ports, and I personally worked with switches with as many as 52 ports per switch, as you can see in the image. Now with these ports, it connects many devices together to form a single network. But a benefit of a switch is that each port has been isolated to its own collision domain because the media is not shared. So you can avoid dealing with collisions. A switch also has intelligence on the devices that are connected to each port, and that intelligence is stored in a table. And frames are only forwarded out the specific port that matches the destination physical address in a process called switching. Broadcasts are forwarded out all of the ports on switch, and error checking is performed per frame. Another benefit of a switch is that it can be chained together to form bigger networks. These are some of the references that I used to make this video, and that's it. Please like and subscribe and leave a comment down below. Let me know what kind of issues that you can see happening at layer 2. Thanks for watching, and I'll see you in the next video where I will talk about layer 3, which is the network layer.